We're moving on to the second section of graphing rational functions. Our first part was finding the domain, and now we're going to go on to the second step, which would be vertical asymptotes and holes. And they are related to each other. That's why we're doing them in the same week. So you have to find the domain first, and then from the domain, after the domain, we're going to find the vertical asymptotes and or holes. So here we go. So how does the domain affect the graph of the rational functions? Well, there are two possibilities. So our first possibility is a vertical asymptote. Vertical asymptotes and a hole. So we have two possibilities. The hole is also called a removable discontinuity. So let's move on to the first possibility. We have them both here and examples of what the equations look like and what the graphs look like. So I'm going to kind of zoom in a little bit. So the first one is a vertical asymptote. And on the graph, they're represented as a dashed line. And yes, you do have to have them on the graph when you graph them. They have to be on there. And I just want to pause for a moment and talk about asymptote. We have talked about them before. Remember, it's a line that the graph approaches but does not ever touch, correct? So it approaches that line, but it never actually touches that line. So here we go. My equation for the first graph is f of x equals x plus 5 times x minus 1 over x minus 3 times x plus 1. And this is what the graph would look like. Notice I have two asymptotes, one at x minus 1, x equals negative 1, and one at x equals 3. And they're denoted by the dashed lines here. Okay. Okay. And on the second graph, this is the second graph in equation is the one where we have a hole. And a hole is how we put that on a graph is as an open circle. Okay, so if I was to look at my graph at my hole, it would be right here. It's at the hole at -1. And I'll show you why it's there in a little bit, but that's just a picture of it. And notice also that this graph does also still have an asymptote at 3. So they're both there. It has a hole and an asymptote, and that usually does happen on a rational function. So we're going to move on to how do we find a vertical asymptote in a hole. And again, there's three steps that we're going to kind of talk about. The first one is oh my goodness, I'm talking so well today, please forgive me, but I am not starting over. So the first thing we're going to do is we're going to factor. So we're going to factor the numerator and the denominator. Oops, and I didn't take my time and I spelled it wrong. Denominator. Okay, so we're going to factor both the top and the bottom this time. So if they're not factored, we need to factor them. We need to make sure that both the top and the bottom are already factored. The second step is find the domain. Remember, find the domain is has everything what we just got done doing in the last lesson is we set the denominator equal to 0. Okay, and then if possible, the third step is if possible we're going to simplify the expression by canceling. You guys know I hate canceling, so I'm going to just put in parentheses make ones. Okay, because that's what we're doing. By canceling common factors in the numerator. And the denominator. Okay, so So what we get is we get two things once we simplify. So we get factors that cancel produce wholes. So anything that I cancel or makes a 1, in that spot there's a whole. And factors that cannot produce vertical asymptotes. And we're going to abbreviate vertical asymptotes as VA. Okay, so we just abbreviate vertical asymptotes as VA so we don't have to write vertical asymptote out every time. I hope you guys are okay with that. So we're just going to kind of go back to our two equations that were given before, and I have them written down here. Here we go. So how do I know? From my equations, I'm going to look. So if I look at F, if I look, there's nothing that cancels. There's nothing that makes 1s. So that means I only have a vertical asymptote. So if I'm going to find my domain, right? I'm going to, what makes my denominator 0, right? Wherever it makes my denominator 0, that's where my vertical asymptotes are. So I may have a vertical asymptote at x equals 3 and x equals -1. And if we remember from my graph, if I highlighted the asymptotes at 3 and -1, and that's how I could tell, because from my equation it tells me I have a 0 at 3 and a 0 at -1. So my vertical asymptotes are where my zeros in the denominator are. Okay, and then for g of x, if we look, I have an x plus 1 on top and an x plus 1 on bottom. So that's canceled out. So that means I have a whole at x equals -1. It's gone. It's canceled. So I have a hole there. And then I have something in the denominator that's not canceled out. Let me highlight that one right here. That's not canceled out. So that means I have a vertical asymptote at x equals 3. And if you remember from my graph before, you can go up and look. You can go back and look. It's I had a hole at -1 and a asymptote at x equals 3. And we are going to put this all together when we get to the graphing part. But right now, all I want you guys to be able to do is tell me where they're located at. Where are my vertical asymptotes at? And where are my holes at, if there are any holes? So that's all we're going to find out. That's all we're going to do, okay, for the next 3 problems. So we have 3 examples that we're going to do. Okay, so here we go to the first one. And I'm going to slide in just a little bit so we can write the steps. So the first thing I'm going to do is just factor, kind of like when we were simplifying the very, very first 5.1 simplifying. That's what we're going to do. So we're going to factor. Number 1, factor. We're going to factor. So I want to factor the top and I want to factor the bottom. And if you notice, they are both trinomials with an x squared. So I have 3 terms with an x squared. So I'm going to factor. So I need 2 terms for the top. So I'm going to do the top or the numerator this time. Give me 2 numbers that multiply to be -15 and add to be 2. Well, what multiplies to be 15 is 3 and 5. And then I know this is negative and this is positive. So the 5 is positive and the 3 is negative. So I know that f of x is going to equal x minus 3 times x plus 5 over, and then I need to factor the denominator, which is -16 plus 6. So let's see. And again, I have a negative on the bottom and a positive on the top. Okay. So what multiplies to be 16? Let's try 8 and 2. I think that works. That's 6 apart. So the bottom's negative, the top is positive. So the 8 is positive and the 2 is negative. So I get x plus 8 and x minus 2. Okay, so I cannot... So step 2 said find the domain. Okay, so I'm going to find the domain of the function. So in order to find my domain, I'm looking only at my denominator. Okay, great. So my domain, I'm going to come over here, is, let's see, x is going to equal -8 and +2. So my domain goes from -infinity to -8, joined with -8 to 2, joined with 2 to infinity. Okay, there's my domain. And then number 3 says we have 2. Does anything cancel out? Nope, nothing cancels out. So that means I have a vertical asymptote at x equals -8 and 1 at x equals 2. Okay, and there we go. There's my answer. Not too bad, not too shabby. So let's try the second one. I can zoom in a little bit more on this one. So again, I need to factor both the top and the bottom, or the numerator and the denominator. So let's start with the numerator. So I need 2 numbers that multiply to be 1 and add to be 2. Well, 1 and 1. There's only 2 numbers that multiply to be 1. So then I get, let's see, g of x is going to equal x plus 1 times x plus 1. And then I need 2 numbers that multiply to be -1 and add to be 0. Now I know I can do this another way. I'm going to show you both ways. I don't have a middle term on this. That means it's going to be 0. So I've got 1 and -1. But if you don't like that way, I know that x squared plus 1, oops, so sorry, that should be -1. X squared minus 1 equals 0. If I set it equal to 0, I can add 1 to both sides, and I get x squared equals 1, square root it, and x is going to equal plus or minus 1. Same thing, plus or minus 1. So I have x plus 1 times x minus 1. Okay, and so my domain is going to be from -infinity to -1, joined with -1 to 1, joined with 1 to infinity. Beautiful. And then let's see, oh, I can cancel out that one. So that means I have a hole at x equals -1, and I have a vertical asymptote at, right here, have a vertical asymptote at x equals +1, right? Okay, how do I know it's +1? I just want to say that because x minus 1 equals 0. Remember I set it equal to 0, add 1, and x equals 1. And that's the same as how do I know my holes at -1? I subtract 1. Okay, here we go for the last one. Okay, here we go. Okay, so I need to factor both the top and the bottom. And luckily for this one, there's nothing to factor in the top, or the numerator. In the bottom, or my denominator, I've got an x squared and an x. So what can I factor out of both of those terms? Well, an x. Beautiful. And if I take an x out of x squared, I get left with x. If I take an x out of x, I get left with 1. Remember, if I multiply this back out, I should get, let me come over here. Remember, if I multiply it back out, I need to get my original equation. So x times x is x squared, and x times -1 is -x. So that's why it factors out to be that. Just wanted to put that as a side there. Okay, so everything's factored. What's my domain? So I know that I have two things multiplied together that equals 0. So I know that I have x equals 0 and I have x minus 1 equals 0. So my domain is going to go from negative infinity to 0. Oops, domain, so sorry. Joined with 0 to 1, joined with 1 to infinity. And then what am I looking for? Oh yeah, I really want to know, do I have any holes? Well, this x and this x go away. So that means I have a hole at x equals 0. And I have a vertical asymptote at where this equals 0, and where that equals 0 is x equals 1. And if you can look in my domain, by the way, this all lines up to my domain. It's all at the point where my unions are. I always have something going on at my union. Either an asymptote or a hole will be in those spots. So if you need to know, that's why we find the domain. Where those spots are, right here, there's something going on. So right here, and right here, there's something going on at -1 and +1. And if we look up here, here, and here, we have something going on. So at -8 and at 2, we have something going on. So that's why the domain helps. It helps you find out where my spots are. So that's it for this week, and how to find the domain and the vertical asymptotes and holes. I believe that you have a Delta Math assignment that covers both of them together, so you only have one Delta Math assignment this week. If you have any questions, please contact your teacher. We will be glad to help you guys out. I hope you have a great week. Talk to you soon. Bye.